Okay, so this one here, so that's the last one of this series. Let's work out the log first. Okay, splitting this all up. The numerator is a positive log. Denominators are all negative logs. Okay, so that x is a minus because it is in the denominator. Log base a of y we worked out to be 3. That's equal to 1. That's equal to 4. And then we're going to square whatever that answer is. 3 minus 5 is 2. Negative 2 squared is 4. So the final answer is 4. Okay, so here we're just going to verify these log laws that we did before. So again, it's really important to make sure you really understand these. If I am dividing arguments, I'm subtracting the logs. Okay, this is true. I get log base 10 of 1 is 0, minus log base 10 of 10 is 1. And so I'm going to get the power here is negative 1. The exponents here work out to be negative 1 as well. So same thing here. This is going to be, I'm going to use my calculator for this one, because 4 and 10 are not related bases. So log of 4 divided by 3 equals 0.125. 0.125. So we're going to check that this works if we apply the log property. If I'm dividing log arguments, I subtract the logs. Okay, so that's going to be, just going to work out the 2 decimals here. Log 4 equals 0.602. 0.602 minus log 3. That's 0.477. 0.477. When I type that into my calculator, yep, I get the same 0.125. Okay. Just changing it up slightly, let's test this log base e button or ln button on your calculator. So ln is exponent on base e. So if regardless of the base, these rules work, right? Doesn't matter what base we're using. So let's just test this log 20. Log 120 is 4.787. Okay, so I get 4.787. So this is maybe the first time that you've encountered log base e. So this is exponent 4.787. The base is e. So if you want to test that it actually works, find the e button on your calculator and do e to the power of that number, and you should get 120 argument back. Okay, so if you're not quite sure about that, you can test it out. Okay, but regardless of the base, even if it's this really weird base e, log property should work. So if I have log 120, that's going to be equal to 4.787. I can test to see if this log property works. If I have factors, I can add the log values or the exponents together. Okay, so let's try this on our calculator. Log 4 equals 1.386. 1.386 plus log 3, log base e of 3 is 1.099. 1.099. And when I add those two numbers together, this is wrong because I have to use base. I did log of 3. It should be log 30. So log base e of 30 is equal to 3.401. Okay, 3.401. Adding those together, I get 4.787. Okay, that works. This power rule should work as well. Okay, so log 8 is 2.079. Okay, so 2.079. So this should be the same as 3 log base 2. I should be able to bring that 3 to the front as a multiplier, power to power. Okay, so I'm going to go log 2. That's going to be 0.693. Okay, 0.693. When I multiply that together, yeah, I get 2.079. Check, that works. So the log properties work whether we're talking about base 10, base E, or any base we want. We generally want to use a base that's kind of common if we can find it. But if there's a common base, like here, we try to evaluate. If there's not a common base, we can still apply log properties to it. And our 3 main rules, before we finish up here, the 3 main rules are this. We have our times inside, we add the logs. Divide inside, we subtract the logs. Okay, we have a power. There's our power rule. Power inside, we can bring that power out because it's a power to power, so we multiply logs.